Bismillahirrahmanirrahim. Welcome to this second lecture on linear control theory. We will go through chapter number 1 from Chen. Let's go through the recap, and then I will explain the different aspects about the linear control theory. For example, what is the role of physical laws and the equations in the linear control theory, how the transfer function model is used and it's different from the actual model of the system. We will see some of the examples and how we use the S domain and time domain systems, some state space model, and the examples also. As a recap, we decided that this course will be consisting of 3 parts. Part 1 will be about the modeling and analysis of linear systems. The second part will be about the controller design of the linear system. And the third part will talk about some topic about the optimal control and others. In the modeling part, we will discuss today's lecture about the introduction. Next chapter, this is chapter number 1 from Chan, and this is chapter number 2 from Chan, in which we discuss in detail the mathematical descriptions of the systems. Chapter number 3 about the linear review, that linear algebra for the linear systems. Chapter 4 is about state space realization, its solutions. Chapter 5 is about the stability, and 6 is about the controllability and observability, right? So today we're gonna talk about in general the linear control theory, its introduction. After completing first part, the second part is divided into the controller design introduction. We will focus on the state feedback, the state estimators, pole placement method, and in optimal control, we will focus on the LQR and the LQG. But before that, we will have a good introduction about the optimal control. So before moving ahead, let's review the basic definitions about the control systems. You must have heard about and studied the control system before. So in control system, we start with something called plant. Sometimes we also call it a process, and it is also taken as system. So these 3 terms are usually used to highlight the system that, or the plant or the process that we are trying to control or make an impact of, or we try to influence it. So this is a real physical object. By the way, this can be a tangible item, and this may be a non-engineering system. Financial system also can be taken as a plant or the process, and we can improve it. So this can be a tangible as well as intangible. So before control it is important to see the behavior of the system. Before we go or control something, it is important we have to have a measure. You cannot control something if you are unable to measure it. And by measurement, what we want is measurement is important because measurement leads us to study the dynamics of the system. I usually use the word dynamic system to represent the process or the plants. And before applying the control, it is important to, before applying the control, it is important to see the behavior of the system. And by that, what I want to emphasize is the dynamics of the system. And we can study the dynamics both in the while we are controlling it or while we are not controlling it. Not controlling or basically in open loop or in the closed loop. By the way, open loop control can be applied in open loop as well as in the closed loop. Okay, so the both of these things are basically related to the control. Okay, and so what I would like to emphasize here is control can be open loop as well as it can be open loop control, as well as we can have a closed loop control. Right. Now, with the control, there is basically an objective that we fulfill. So in control, objective is something we clearly mention what we are going to achieve. And then this whole thing, there are some characters, like there are some signals which are treated as the input. This is the signal that you are using to control the plant. So this is generated by the controller. So we usually call it or represent it with U of t. So this is the input signal that the controller is generating. And the control objective is here as an algorithm. The control objective will come here as sometimes as an algorithm or a program, right? This can, by the way, this controller can be an electronic device. It may be in the field. It can be a programmable logic controller. It may be your small Arduino board or some other. It can be even a computer, your personal computer or something. So this controller is normally having some kind of a micro controller or microprocessor. Second thing is the outputs. What outputs are? These are basically where we actually put our sensors on the system or the plant, and we start taking the measurements. So here comes the data, the crucial data. So here we've actually put, and we start measurements here, right? Okay, so then we have the process, or the process is what's happening inside the plant due to the inputs. This is related to the dynamics. Okay, and then we have the model. Of course, this model will be like mathematical representation. It is mainly the equations that we use to represent the physics of the system. And then we have the disturbances. So we have to have a good understanding about what is a plant, what is the control objective, inputs, outputs, process, model, and disturbances. Okay, so at this point, I would like to pause and wait for any questions. क्या कुछ सवाल है तो kindly मुझे बताइए. Okay, this slide is clear to all? तो इसमें कोई issue तो नहीं है? जी मसूद.
जी सर.
इसमें इस slide में तो कोई issue नहीं है. It's clear to you? Basic definition.
No sir.
Okay, thank you. Okay, अब हम एक एग्जाम्पल देखते हैं, और this example is about ट्रैफिक कंट्रोल, कि किस तरह ट्रैफिक कंट्रोल के अंदर हम अप्लाई करते हैं प्लांट. तो प्लांट क्या होगा? द प्लांट विल बी द ट्रांसपोर्टेशन नेटवर्क. ओके, एंड इसमें सारी की सारी चीज़ें आ जाएंगी. एवरीथिंग विल बी इन दिस plant, treated as a plant or system. And the process will refer to the movement or the operation, right? Operation of the plant. And this process is basically reflecting and generating the dynamics of the system. Okay. अच्छा, इसके अलावा इस सिस्टम में we can have multiple control objectives depending upon your situation. For example, few of the control objectives can be you want to minimize the traffic. For example, this may be one. We may have another objective which is avoiding a traffic congestion. We may have an objective of avoiding the accidents. Maybe in some areas कहीं पे traffic इस तरह की हो सकती है कि we may have frequent accidents. So on that, we may have a different control objective on this spot के यहाँ पे accidents कम से कम. And sometimes we need to avoid the delays. So the control objective may be, we may have multiple or different control objectives as per the requirement, right? Control objective तो हमें clients या situation wise different हो सकते हैं. इसमें inputs क्या हैं? Inputs, we discussed that input will be the U of T signal जो कि controller generate करेगा. It is generated by the controller. Okay. इसके अलावा जो output है, this is for example cars movement और भी बहुत से हो सकते हैं. This is what the sensors are going to give us. Sensors will give or provide measurements, right? तो जिस information की ज़रूरत होगी, we will put it there. Cars movement हो गई, number of cars is another good thing, and other things. अच्छा, what kind of disturbances may you have deployed everything, but there might be some disturbances. For example, we were trying to avoid some accidents, but if something happens like accident, the road blockage भी हो सकती है. We may have some bad drivers within the, you have the signals, but someone may not follow the rules, signal toward them or other things. We may have a rain here, road blockage. So these are all things which we are actually trying to avoid, but they may happen. So what will happen? The controls किस तरह से काम करेगा जब आपके पास disturbances हैं. So for everything as a control engineer, what we have to do is we should start from here. उस system का सबसे पहले हमको एक block बनाना होता है, and then we identify what are its outputs or measurements. Then we mention what can be its inputs controlling. We club them together, और फिर हम यहाँ पर इसका कोई controller design करते हैं, and we fed the controller with the set points as well as the feedback from this. So this is your overview, this is error, this is Y measurement. Okay, and there might be multiple Y's, multiple U's, and the control actions. Okay. Now, इसके अलावा और जो control system के examples हैं, for example, human body के temperature control system is an excellent example. Thermostat, AC, turning heater or cooler for the desired cruise control, maintaining a speed against the disturbances. Robot control system जिसमें हम voltage को apply करते हैं to the motors. Motors are basically the actuators, right? The controller, a kind of PID controller, may be sending a signal to the actuator, which is motor, and the PID output may be a voltage. ये voltage apply करेगा, it will vary the voltage, and the motor speed will change and stop at different positions. Robots के केस में हम दो किस्म के काम करते हैं. Number one, एक तो position control है, और दूसरा काम उसका speed control, right? In nature, आपके पास control actions हैं. So I was thinking कि एक अगर, if you follow and do this task, I will assign as an homework simply to think about some other control example जो आपको fascinate करती है, and try to highlight and identify what is the process here, what is the control objective, disturbances, inputs, or sensing क्या है. Okay, so there it will be your control system, okay, that you like. Next we have few which remarks हैं जो मैंने ऐड किए हैं to make things clear so that कि हम directions properly we can study well. So the course on controls जो है, this is basically generally deals with the dynamics, because something is happening to the system, and dynamics means system is changing. By dynamics, what we mean is, dynamics means there is some change in the system with time. Sometimes we want this change, sometimes this change is wanted, desired, okay, and sometimes this change is unwanted, yeah, undesired, okay. In दोनों केस, undesired के केस में we need to use a control action to improve it, जिसके लिए हम फिर feedback control use करते हैं, feedback control, okay. So the dynamics plays the key role, and such changes refer to the behavior of the system against different inputs, situations and disturbances. So dynamics is all about कि किस तरह system आपका behave कर रहा है, and system will change maybe because of your desired inputs. आपने खुद step input दिया है कोई, ठीक है, आपका production, maybe the generator you are running maybe at different speed, different situation हो सकती है load की, और disturbances भी हो सकती हैं जो कि undesired है. तो inputs जो हैं आपकी desired भी हो सकती हैं, desired set points, and they may be undesired inputs, जो इनको हम undesired inputs को हम कहते हैं disturbances, okay. So ये disturbances जो हैं ये कुछ भी नहीं है बल्कि ये undesired inputs हैं. Example के तौर पे, for example, a flying drone, इसके coordinates change होंगे during its course. So this is a desired thing. Drone is moving, flying somewhere. कोई drone हो सकता है that is moving from one place to some other place, desired place पे जा रहा है ये, ठीक है, okay. Change of speed and acceleration of a car और उसकी consumption, ये पूरी चीज़ जब आप observe करेंगे तो this actually जो with the passage of time जो dynamics हमारे पास उसकी speed की आएंगी, okay, with respect to time. So this is the dynamics. Power systems and variations of the loads and duration. For example, अभी disturbance हुई, हम light, we face a heavy blackout, हर जगह light चली गई थी, for example. It may be because of some disturbance, and then some control actions उसको restore किया और फिर now it's back. So in सारी situations को, this is all sometimes disturbance की वजह से एक chaos आता है, उसको avoid करने के लिए we have to understand the dynamics. Our best friend is the equations. These equations are our best friend because they help us to represent and deal with the dynamics. Okay, mathematics, it looks like odd initially, लेकिन this is the thing, or this is the key. Mathematics is the key जो कि equations जिनको आप कह रहे हैं, these are the keys जिसकी वजह से systems engineers, physicists, engineers, actually they are able to design and improve things, ठीक है, and even to study. Without having proper equations, we cannot even study any system, ठीक है. So these are the some comments regarding the physical laws and the models that we are going to study. Few more remarks about it. We should be careful कि dynamics और जो physical phenomena है इसके पीछे the physics and maths are playing their role. For example, circuits को भी जब हमने first time study किया था, तो okay, if the circuit is like this, okay, we put some capacitors here, okay, and some maybe inductor here, and we have a voltage at input 20 sine or some omega t, and then I ask you, अच्छा यहाँ पे current क्या होगा? This is 10 kilo, this is 1, this is also 10k, this is also 10k, this is 1k, let's say, this is a 0.1 pico, this is 1 Henry let's say, तो यहाँ पे voltage जो है वो क्या होगा. So even in this case we actually went through the equations and the laws. ठीक है, तो हमने KCL KVL के जो laws हैं उनकी basis पे we were able to make the analysis and finally हम उसको verify करते थे labs में. So this was our first or beginning style of study. But there is one important thing कि even this system is very complex. So हम इसका भी एक approximated model बना के उसको solve करते हैं, simplified. So real systems are actually very complex, but and sometimes including all the data. For example, इसमें जितना भी इसका the heat dissipation है वो हम ignore करते हैं. When we talk about KCL KVL, we ignore the thermodynamic effect or heat effect, right? So we actually, what we do is we actually focus on the doable models. अब doable models यानी कि ये simplified models हैं, वो models जो हमारे काम को आसान कर दें, ठीक है, they actually help us. Simplified models, simplified representations. So simplified representations जो हैं, for example, V equals to IR. This is a good model, but this will not be talking about any temperature variation in it. कि करंट के साथ जैसे जैसे करंट बढ़ेगा इसके टेम्परेचर वेरिएशन भी होगी, बट इन और उसकी वजह से वोल्टेज में भी वेरिएशन आएगी, बट इन दिस मॉडल वी डोंट हैव एनी टेम्परेचर वेरिएशन. ठीक है, सो ये सिंप्लीफाइड मॉडल है V equals to IR. And if we talk about R is equals to rho L upon A. So इसका अगर आप और वेरीफाई करें V equals to I और R को आप rho L upon A कर देंगे, तो इसका मतलब ये होगा कि आपने थोड़ी और डिटेल. एंड देन फर्दर अगर रो को भी आप टेम्परेचर डिपेंडेंट लेके चले जाते हैं, इसकी कोई इक्वेशन हो, इफ आई रिप्रेजेंट रो as a function of t and there is a function of temperature. जी कोई सवाल है? Any question?
No, sir.
Okay. Okay. So what I was focusing on कि practically देखें तो कोई भी इक्वेशन जब आपने मॉडल इस्तेमाल किया है, इससे ज़्यादा कॉम्प्लिकेटेड मॉडल आपके पास बन सकता है. सो द कॉम्प्लिकेटेड मॉडल ऑफ अ रेजिस्टर कैन बी लाइक I L upon A and rho of temperature. So this V equals to IR was the simplified model, and but this is a little detailed model in which we are taking care of the temperature. और ये temperature हो सकता है कि ये equation हो आपके पास, for example, alpha times T plus alpha 0, alpha 1 times T square plus alpha 2 times T cube. ठीक है, and this whole thing will become like और इसकी जगह पे यू कैन एज्यूम के आप अल्फा टी प्लस अल्फा 1 टी स्क्वायर और अल्फा 2 टी क्यूब लिखें. ओके, सो व्हाट आई एम ट्राइंग टू एम्फसिस हियर इज के ये जो रिप्रेजेंटेशंस हैं हमारे पास, दे आर कॉल्ड एक्चुअली द मॉडल्स. सो फॉर अ रजिस्टर व्हाट वी हैव सीन हियर इज कि एक रजिस्टर के लिए ही वी कैन हैव अ सिंपल V equals to IR model, as well as we can have a detailed model which is, for example, here जैसे हमने बनाया VIL upon A, or this can be, let's say, alpha naught T plus alpha 1 T square plus alpha 2 T cube, and there might be some other, ठीक है, third order model. So this becomes a very complex model. लेकिन जब आप स्टडी कर रहे हो रजिस्टर का की डिपेंडेंस वोल्टेज वेरिएशंस, सो दिस मॉडल इट्स कॉम्प्लेक्स मॉडल, लेकिन इसमें फ़ायदा क्या है, इसमें आपको जो वोल्टेज है, वोल्टेज एज अ फंक्शन ऑफ टेम्परेचर वेरिएशन in register. जबकि this is a simple model जो कि depend करता है depending on current and register, or register is taken as a constant. ठीक है, इस मॉडल में रजिस्टर कांस्टेंट नहीं है, इस मॉडल में आपके पास रजिस्टर कांस्टेंट है। सो आपने देखा कि आपके पास एक से ज्यादा मॉडल हो सकते हैं इसी सेम चीज के। ओके ओके, इट्स क्लियर। आई विल पॉज फॉर अ मिनट। ये समझ में आया कि दिस इज हाउ इक्वेशंस आर हेल्पिंग अस, दे आर आवर फ्रेंड्स, और एक ही चीज के एक से ज्यादा मॉडल्स बन जाते हैं। सो हैविंग द राइट मॉडल इज वेरी इंपॉर्टेंट। ओके, now I will move to the introduction. I will try to follow the same sequence as in the chapter 1 of the chain book, ताकि हमारे पास अच्छा reference रहे, उसी के numericals भी हम solve करेंगे। Now coming back here, the study and design of any physical system can be carried out using two methods. एक मेथड है आपके पास empirical methods, जिसको आप कहते हैं, इसको आप black box method भी कहते हैं, system identification भी। So one method जिसको हम कहते हैं empirical method or black box strategy, it is basically based on the data. यानी आप कुछ input apply करेंगे और output को observe करेंगे. So we apply a signal, for example a step. System might be at 0, आपने उसका step apply किया 10 units का, and you start observing the output with respect to the time, और output जो है इसकी किस तरह से vary कर रही है. So this will be your y of t, and this from input output data, input and output data, we conduct some kind of identification and figure out कि इसका relationship क्या है, यानी हम ये find out करते हैं y upon u जो है ये क्या होगा, right? The second method is called analytical method, which is basically a sort of a model-based strategy. इसमें we use laws, physical laws, physical chemical laws, और हम by law चलते हुए इसकी equation को drive करते हैं. This HS is basically y of s divided by u of s. ठीक है, यानी कि output divided by input, इसका जो आपके पास पूरा मेथड बनेगा. So these are the two basic ways or techniques even in control and system identification. ये दोनों आपके controls में और system identification में as well as किसी भी किस्म के data analysis में ये काम करता है. ठीक है. A little comparison between the black box strategy and the model based strategy. Black box strategy में basically we learn by training. It is similar to I'm talking about like data, yeah, you can connect it with the artificial intelligence जिसमें you provide the data और AI is going to help us in figuring out कि वो relationship क्या है दोनों की. लेकिन we will have no idea about the real meaning internally, what's going on. हम सिर्फ end to end इसका benefit निकाल सकते हैं relationship. So there is no idea what processes are happening inside your system, क्योंकि हमारे पास सिर्फ access क्या है, हमारे पास है you, the process and its result. So this is the result. अब इसके बीच में अगर आपके पास कुछ एक से ज़्यादा कहीं पे कोई signals हैं, तो we will not have the internal idea. We will have only the idea about the result. अच्छा, end result आपके पास क्या आ रहा है. So input और output, इसको आप external description भी कह सकते हैं. इसका नुकसान क्या है? इसका नुकसान है we cannot analyze. Analyze means we cannot see inside. ठीक है, inside जो view है, inside view is difficult, is very difficult. Okay. या अगर आपको थोड़ा बहुत आइडिया भी हो जाए तो लेकिन उसकी कोई फिजिकल अंडरस्टैंडिंग नहीं होगी. ठीक है. अच्छा, यही एडवांटेज में भी काउंट होता है कि आपको कोई फिजिकल अंडरस्टैंडिंग की ज़रूरत भी नहीं है बाय लॉज के अंदर चीज़ें हो क्या नहीं. सो एज फार एज यू आर only focused on the end results, it's good. Second is the model based strategy. इस मॉडल बेस्ड स्ट्रेटजी में हम इक्वेशंस और फिजिक्स को यूज करते हुए इसका पहले मैथमेटिकल मॉडल बनाते हैं, उसके बाद फिर हम इक्वेशंस डेवलप करते हैं टू रिलेट द इनपुट्स एंड आउटपुट्स. सो इट कैन बी, फॉर एग्जांपल, अगर मैं दोबारा इसी सिस्टम को बनाऊं, if I have this system here, and we have V in here, we have V out here, यहाँ पे R1 है, R2 है, R3 है, C1 है, C2 है. तो इसमें अगर मुझको इस पूरे सिस्टम में अगर मुझे V out upon V in चाहिए, if this is a system जिसकी आउटपुट जो है V out है और जिसके इनपुट जो है V in है, यानी this is your U of t, V out is your Y of t. So इस केस में अगर आप फिगर आउट करना चाहेंगे तो you have to find out, you have to apply the KCL here in nodes के ऊपर. Okay, you have to define node number 1 is this, node number 2 is this one. You apply KCL, KVL, and then you figure out, पहले आपको ये करंट I1 निकालना होगा, then I2, then I3. ठीक है, ये वोल्टेज V1 वोल्टेज निकालेंगे, V2 वोल्टेज निकालेंगे, एंड फाइनली हियर फॉर एग्जांपल यहाँ पे जो V out का वोल्टेज है, सो वी मे हैव 1, 2 और 3 इक्वेशंस होंगी हमारे पहले, तकरीबन 3 इक्वेशंस बनेंगी, फिर उनको आप सॉल्व करेंगे एंड फाइनली यू विल सम अप देम टू फिगर आउट कि अच्छा वी आउट. वी विल डू दिस एक्सरसाइज लेटर ऑन. लेकिन इसमें होता क्या है, इसमें हम मुख्तलिफ इक्वेशंस को पहले डेवलप करते हैं. सो दिस माइट बी 3 इक्वेशंस इनिशियली, फिर इन इक्वेशंस को हम सॉल्व करते हैं एंड वी फिगर आउट द वन इक्वेशन रिलेटिंग आउटपुट एंड इनपुट. ठीक है, सो फर्स्ट आपके पास जो इक्वेशन इसमें बनेगी दैट माइट बी वी इन रिलेटिंग V1, फिर आपके पास V1 रिलेटिंग V2, and then finally V2 relating V out, and then we solve them together so that कि आपका ये direct link एक equation से develop हो जाए. ठीक है, so this slide is also clear to you. इसमें भी कोई question तो नहीं है. We will, when इसकी जब हम one by one sample करेंगे, that will be good. But this is the overall. Black box strategy में we will have no idea about the internal circuit. हम V out और V in हम डायरेक्टली इसके ऊपर V कोई सिग्नल अप्लाई करेंगे इनपुट पे. ठीक है, with respect to time, let's say from 0 to 5 volts, and we observe the output. It may come like this, और फिर इससे हम there are some methods and through which we directly use V in, और ये इसका हमारे पास कोई इक्वेशन आ जाएगी s minus 1 upon let's say s square plus 2s plus 5 through some identification. But we will have no idea about कि इसमें I2 क्या है, इसमें V1 क्या होगा, इसमें V2 क्या होगा. ठीक है, ये दोनों हमारे पास कोई आइडिया नहीं होगा. Okay, so this is the advantages and disadvantages in both cases. Now coming back to the empirical method. Empirical method में हमारे पास so in empirical methods we apply various control signals to the physical system and measure their responses. And if the outcome or the performance of the system is not satisfactory, we can develop some controllers. In controllers को हम compensators भी कहते हैं, and they actually help us to adjust the performance. So in empirical method, it is heavily dependent on your previous experience, past experience, and most of the time we actually do trial and error. Okay, so and many physical systems are being developed with empirical, so this is very useful method as well. But there are some issues with the empirical method. For example, this may not become workable if physical systems. So this may become unworkable if physical systems are too complex, or too expensive or too dangerous to be expensive. So it looks like it is easy कि मैं apply करूँ कोई signal, apply a signal and get the result and apply the identification. But sometimes the system is not available for your experiment, not available for experiment and collect data. Okay, in that case, you have to go and work out the analytical method step by step. This becomes like indispensable, very essential and necessary for the study of the design of the complex system. For example, power systems and the grid, smart grids and quadcopters, and for example, you have to have. So as a control engineer, you should be good in both method and should be able to use the appropriate ones. Now coming to the analytical method, much have been developed. Basically, the first things in any field are being developed mostly by using the analytical method, and this is the most consistent method in the field. Now there are some very, it is well developed. So we have very good description of how to use this. The first part is modeling. The second, modeling means you describe your the physics of the system, how the things are interconnected. It is how the things will go, flow, how they are interconnected. The second step comes here after having this. This is similar to the in the industry process flow or the recipe. Okay, so and then comes the second thing about, okay, how the things are connected, we know, and then we develop the mathematical descriptions, okay, with respect to every system, how the systems are doing. The third thing comes here, the analysis. We verify by running the simulations of the mathematical equations, the overall system, and go back and validate with the process outcome. And finally, we will focus on the design improvements. By this design means actually the controller or the compensator that we are looking to design. Okay, so in next slides, we will briefly introduce each of these tasks in the next part.